In this video, I'll show you how to download and install OpenOffice, and then use OpenOffice spreadsheet to do linear regression. So first, open your web browser, use Google to search for OpenOffice Windows 10. And then you'll see this web links, OpenOffice, OpenOffice download. So we'll download this software. Over here, you can see a list of operating systems. We're going to do Windows, but also you can choose Linux or Macintosh. And then you click download for installation. You will download this software, the entire package. I did this already. It's on my desktop. So it ends with exe. It's an executable file. So double click this. And then click yes and follow the instructions, and then you can install the entire OpenOffice suite. But I did that already, so I'm gonna click no. Alright, so after you install this OpenOffice, you will see OpenOffice 4.1.7. This is the latest version as of today. So double click this. Since we're gonna do data analysis, click spreadsheet. This corresponds to Microsoft Word. This corresponds to Microsoft PowerPoint, but we're gonna just do a spreadsheet. All right, so I'm gonna make it a little bigger so you can see more clearly. I'm gonna give you an example today. Let's say we will mix water and ethanol together, and then we will compare the mass of the mixture with the sum of the mass of water and the mass of ethanol. This is to determine if mass is an additive or a non-additive property. All right. So now let's say water is our liquid 1. 2 is ethanol. Well, you can use any label, 1, 2, or AB. It doesn't really matter. So mass 1. That's the mass of water, and then we're going to do mass 2. And then we have mass 1 plus mass 2. All right, this is auto correction. And then the mass of mixture, also in grams. Now I'm going to give you fake data. Let's say we mix maybe 1.000 gram of water and maybe another amount of ethanol. All right, ethanol, let's say 0.793. Okay, so you can see this Excel. Oh, I'm sorry, the OpenOffice spreadsheet converts 1.000 to 1 automatically. This is fine mathematically, but for scientists, this is wrong because we need to pay attention to the number of stick figures. So in this case, I'm going to use maybe 3 decimal places because typical analytical balances can give us 3 decimal places. All right, so right click, and then I'm going to click Format Cell. So what I did is I highlighted this area, all this 20 cells, and then I right click to see a list of options. I see this Format Cells, and then I choose number, and then I'm going to look at this decimal places. I'll change it to 4 or maybe 3. Let's say 4, and click OK. 4 decimal places, that means we have an analytical balance with a precision of 0.1 milligram or 0.0001 gram. All right, now let's compute the sum. To compute the sum, you can just use this equation. You type this equal sign and then say B5 cell, so B5 plus, and then C5. All right, that's it. So this will calculate the sum for you. And then let's do some other numbers, maybe 1.998. Over here, 1.4567. Those are fake numbers. 2.9999. And over here, 2.299.4 grams. All right, and then I'll get one more number. close to 3. So we want to scatter our data. So maybe 3.001. Over here, let's do 2.3457. Okay, let's do 5 data points. 4.9998. Over here, let's do 3.4567. Maybe this number is a bit too big for ethanol, or too small for ethanol. So a more realistic number, I think it's going to be all right. So now we have 5 data points. This 10 numbers are fake data. And then I'm going to compute the sum of these 2 numbers by just clicking this cell and look for a filled square on the bottom right corner, very small, and drag it down to here. Also, you can drag it down all the way to the 5th row, and now we have the sum. All right, so these 5 numbers are the sums of these 5 pairs. Now let's imagine we measure the mass of the mixture. Okay, so let's say it's 1.79 and 3.4499. And again, I'm making up those numbers. So let's see, 5.2889. Oh, okay. In this case, it's a little too small. So I'm gonna change it to roughly 4. I'm gonna change this number to roughly 9. All right. Okay. So the reason I changed this data point is now I'm making this a bit more reasonable for water and ethanol, assuming I'm using 5 milliliters of each liquid. All right. So this one's 6.9000. And then this one's 8.7000. Okay. All right. So now we have 2 columns here. We're gonna make a graph using these 2 columns. All right. I selected these 2 columns, and then you look for this chart icon. So click this. There are different kinds of charts. This is the default. But we're not going to use the default chart. We're going to change it. So we'll change it to XY scatter. So right here, XY scatter. And click finish. This is really big, so I'm going to make it a little smaller. All right, this is too small. I will delete this. This is the legend for the data series. And then right click here. So this is the chart area. So outside the data plot, but inside the graph, right click. And then we can insert titles, insert legend, insert, or delete axis. So let's just insert titles here. So the titles are mixing water and ethanol. Well, you can use your own title like mixture of water and ethanol, or the mass of the mixture of water and ethanol. And then you can have a subtitle. I will label the x-axis. The x-axis is the horizontal axis. That's M1 plus M2 in grams. The y-axis is a mixture of the mass. So I'm going to say, well, a mixture also in grams. And then I will click OK. You will see the title here and the labels here and here. All right, they are labeled. Well, again, it's up to you how to adjust the area, the chart area. This is to move it, and then you can also carefully change the height and width. And now we're going to do a linear regression. There are 5 data points. So right click any one of the 5. So right click, and then you can see a list of options. So we will insert the trend line. All right. And you see the trend line over here. And we'll look at the type. I think we're going to do linear. And we'll show the equation. And we'll show this coefficient of determination r squared. I will explain this r squared a bit later. Now we have this equation with many sig figures. This is okay, again, mathematically, but not okay scientifically. So if you look at our data points, we have 5 sig figures. So over here, we should keep only 5 sig figures. So right-click this equation, and then format. Now we're going to look for numbers. Let's see. This category number over here and decimal places. Let's use 4 decimal places, or maybe 5. All right, click OK. All right, so this is the right number of sig figures. 5 sig figures, 5 sig figures. All right. Oh, this one has 4 sig figures, but that's okay. We have a small intercept. I did not find a way to set the intercept to be 0, so we will just leave it here. All right. Ideally or theoretically, the mass of the mixture should be proportional to the mass of water plus the mass of ethanol. The intercept has no physical meaning. All right. But in this case, I think it's nice for us to show that the experimental data are not always ideal. All right. Okay, now you have this equation. You can see the mass of the mixture is not exactly the same as the sum of the mass of individual liquids, but that's fine. I intentionally made these numbers different from these numbers because, again, when you pour a liquid from a container to another container, or from one graduated cylinder to another cylinder, there's going to be some transfer loss. It's impossible for you to transfer a liquid 100%. So intentionally, I made these numbers slightly smaller than these numbers. All right, so just imagine in the original container where you pour the liquid from, you have maybe just a tiny drop left in the original container. All right, so this is how you do linear regression, how you make this OpenOffice spreadsheet and the graph and the linear regression. Finally, I explain this r squared value. If this r squared is equal to 1, then we are looking at a perfect fitting. So this equation fits the data perfectly. In our case, it's very close to 1. So I would say this linear equation fits the 5 data points nearly perfectly. Well, what if r squared is equal to 0? Well, that means there's no correlation between your equation and the data point. Your equation is just useless. This is r squared. R squared can only be between 0 and 1. Again, 1 is perfect fitting, and 0 means no correlation at all. All right, and finally, we're going to save this. So File, and then Save. I'm going to save this to my desktop so it's easier to find. And in this case, I'm going to say, well, the name, maybe just mass. The extension is ODS. This is the file extension for OpenOffice spreadsheet. Okay, save. And then I'm going to close it. All right, it's done. And then you can reopen this mass ODS. If you right-click mass ODS and click Open With, you see I have Excel, I have OpenOffice. So I'm going to use OpenOffice Calc to open it up. You can also use Microsoft Excel to open this same file. So it's compatible. So again, we have labels 1 and 2 for water and ethanol. We have this 2, all fake data. This is the sum of the 5 pairs of data, and these 5 numbers are also fake data. And then you make the graph here. You do linear regression by clicking one of the 5 data points, and then you add the trend line, in this case. The trend line equation and r squared value. Again, when r squared is equal to 1, it's perfect fitting. When r squared is equal to 0, that means no correlation at all.